Example 10. Suppose 2,500 is invested, that makes it the P number, at 3%, that's R, in an account for 10 years, that's T. Find the amounts in the account, so we're finding A. At the end of 10 years, if the interest is compounding quarterly, monthly, daily, and continuously. So they want me to do this problem 4 times. Quarterly means n equals 4. Monthly means n equals 12. Daily, of course, means n equals 365. And continuously, there is no n, it's e. So you have a different equation. So let's look at quarterly first. Quarterly. You're finding A, so it's going to be A equals 2,500 times 1 plus the interest rate was 3%. Quarterly means 4 times, and so that's going to be 4 times 10 years. And so let's hold off. We'll look at the formula for monthly next. Monthly. A equals 2,500 times 1 plus same interest rate, but this time monthly is 12. So the interest is going to compound 12 times 10 years. So if you notice, it's really the same formula, except quarterly, the interest, the exponent is going to be 40, and in monthly, the exponent is going to be 120. So that's telling you how many times the interest is going to compound. And then we've got daily. So A equals 2,500 times 1 plus 0.03 over 365 to the 365 times 10. Okay, now continuously, A equals 2,500 times e to the 0.03, remember it's the PERT equation, r times t is 10. Okay, so really you should probably try to calculate these yourself, use a calculator, and try that out. So pause this right now and try to come up with these numbers on your calculator. Checking your results. Hopefully you got the same things that I did. One thing to notice, you should pay attention to the values and notice that the more frequently the interest is compounded, the higher the number. So continuous compounding has the highest final value. Now it's not a whole lot higher than, what was that, quarterly? It's not a whole lot higher, but it's definitely more. So the more frequently you compound the interest, the higher the number is going to be. Example 11. If current trends of burning fossil fuels and deforestation continue, then future amounts of atmospheric carbon dioxide in parts per million will increase as shown in this table. The data can be modeled by this function. A, what will be the atmospheric carbon dioxide level in 2015? Really, this is just a plug and chug. So we've got the formula, and we're going to plug that in. We're plugging in 2015. So we want to know what that y number will equal. So obviously we need a calculator, and I've already plugged it in. So you plug in that number and you're going to get 414.6 about. Okay, so I notice in my chart they don't have any decimal numbers, so we're going to round off here. We're going to say about 415 parts per million. Part B, use a graph to estimate when the carbon dioxide level will be twice what it was in 2000. We're going to want a graphing calculator for this, so hopefully you have a graphing calculator or something. But anyway, before we start, we want to know something about twice what it was in 2000. If you look at 2000, it's 375 parts per million. So if you double that, we're going to have something to do with 750 parts per million. That's twice what it was in 2000. So I've already got the equation typed in on my TI, and if you graph it, it's going to be hard for you because your window is probably not going to be set right. And so you really have to look at this chart and the numbers like the years between 1990 and 2275 and your carbon dioxide between 353 and 2000. And you kind of have to set the window so that those numbers are all going to show up. And so if I go to my window here on the calculator, you can see I set my X numbers from -10 to 2300. That's going to get my years. And I set my Y from -10 to 2100. That's going to get my carbon dioxide levels. So you really need to look at that. Otherwise, you'll never be able to see your graph. So what they're asking me to do in this is figure out when the carbon dioxide is 750 parts per million, basically, twice what it was in 2000. So I think the easiest way to do that is to go in here and type another equation in. Let's just see where 750 is. And so you can see 750 is going to intersect, and you can see where it intersects our curve. So what you want to do is calculate the intersection. And so it's going to ask you a question down there at the bottom of the screen. It says first curve. So if you move around, you should notice that cursor is on one of the curves. So enter to select that. And now it says second curve, and you notice it's on the red line instead of the blue line. And now it wants me to guess. So you want to try to place the cursor over pretty close to where that intersection is. Okay, and so it's going to calculate the intersection. You see down there at the bottom of the screen it says x equals 2112.3 and y is 750. Okay, so we can see from that screen that the year is going to be about 2112. And we did that on a TI. All right. Now, I really think Desmos is easier to use. So if you go to Desmos and type that in, you're going to have the same problem with the window. You're not going to be able to see it. But if you zoom, I think it's a lot easier to zoom and find it on Desmos. So you can zoom around and find it a lot easier. And then type in that second equation. You want y equals 750. And then you can just click on it. And that shows you your 2112 a lot faster, I think. I'd much rather use Desmos than that TI. But of course the TI is awesome, but there are other tools besides TI. So we've got our answer 2112, or the year 2112.